Welcome to Pi Engineering. In our last session, we have seen about the definition of the power series and some of its examples and how to find the center of the power series. In this section, we will see how to find the radius of convergence and the interval of convergence of the given power series with an example. The interval of convergence is a set of value of x for which f of x will be less than 1, where f of x is the result of the generalized ratio test or root test, i.e. if f of x is equal to lim of an plus 1 over an as n approach to infinity, or is equal to lim of absolute square root of absolute value of an, this as an approach to infinity. F of x is the values, those expressions, and the endpoints we have seen in last session. Here we have seen here we got here those endpoints will be tested individually at f of x equal to 1 out of f(x) equal to 1 individually, and depending on the result obtained, those endpoints may be included or excluded from the interval of convergence of the given series. If the series converges at that endpoint will be included into the interval of convergence. Otherwise, it will be excluded. This means if f of x satisfies this condition, i.e. if f of x or f of f at that endpoint become less than 1, so that endpoint will be included in the interval of convergence of the given series. Let us elaborate this with an example. Let's say a summation as m run from 0 to infinity of x power of n over n factorial. In this example, let's follow steps to find the radius of convergence in the interval of convergence of this series. So by using ratio test, we have limit of absolute value of an plus 1 over an as n approach to infinity. This limit, from this we have an plus 1 here. This is an, so we have an plus 1 x raised to n plus 1 over n plus 1 factorial, and an is equal to x power of n over n factorial. So let's find the generalized ratio test by using those two terms. From this we have limit absolute value of x power of n, means x power of n times x over n plus 1 factorial. This division will be changed into multiplication with an inversion, n factorial over x power of n approach to infinity. This equal with limit of absolute value of x power of n will be cancelled, x over x n plus 1 times n factorial, because I think you know the factorial. N factorial means n times n minus 1 times up to 1 factorial. So up to 0 factorial, we can say 1 factorial because 0 factorial is 1. Here the result is n times n factorial over 1 because x cancelled as n approach to infinity. So we have here n will be cancelled. This equal with limit of here x is independent variable because our limit depends on n. So this result is n 1 over n plus 1 times x as n approach to infinity. As n approach to infinity, our limit, this limit become 0, which is 0 times x is equal to 0. So from our last session, we have seen 3 cases, and this case is the first case. This case, or this case, it is this case. So from this case, if the result of generalized ratio test become 0, then the radius of convergence will equal to infinity, and interval of convergence become from negative infinity to a positive infinity. So here we obtained the result of the our limit become 0. So we have radius of convergence. Radius of convergence is equal to infinity, and interval of convergence is equal to from negative infinity to positive infinity. Let's see another example. Let me say b summation as n run from 0 to infinity of x minus 4 raised to n over n times 3 power of n. This is for 1 to infinity. In this part we have an which is equal to x minus 4 raised to n over n times 3 power of n. This is our an, and from this our an plus 1 is equal to x minus 4 times n plus 1 over n plus 1 times 3 power of n plus 1. So by using generalized ratio test, we'll find our ratio test, our f of x, the value of f of x. So let's go ahead. From this we have a limit of absolute value of an plus 1 over an as n approach to infinity became limit of absolute value. Here we have an plus 1 x minus 4 raised to n plus 1 over n plus 1 times 3 raised to n plus 1 times n times 3 power of n over x minus 4 raised to n. So as n equals to infinity, here we have our limit become limit of n equals to infinity of absolute value. Here x minus 4 times x minus 4 raised to n, this part, over n plus 1 times 3 power of n times 3, this times n times 3 power of n over x minus 4 power of n. So this will be cancelled, and this will be cancelled. This result is in limit of absolute value of x minus 4 times n over 3 into n plus 1. Here in this part, x minus 4 over 3 is a independent variable because our limits depend on n value of n. So this equal with limit of absolute value. This is n over n plus 1 times x minus 4 over 3. So what's the result of this limit? The result of this limit become 1. This become 1. So 1 times x minus 4 over 3, x minus 4 over 3 we got here. So this is f of x. Since we are finding the value of radius of convergence of the given series, just we have to look on which interval our series will be converged. So, but in this case we have seen f of x must be less than 1 for our series to become a convergent. So to fulfill this case, we use this f of x must be less than 1. So from here, x minus 4, this is under absolute value, over 3 will be less than 1. From here, we have absolute value of x minus 4 is less than 3. This result is in negative 3 is less than x minus 4 is less than 3. So by adding 4 to both sides, we have 1 is less than x is less than 7. So now we are in the third case. In third case, this means our interval of convergence became like this: minus r plus c is less than x is less than r plus c. So our interval of convergence will be like negative r plus c comma r plus c, negative r plus c comma r plus c. So here our interval of convergence may be 1, 7 or 1, 7 or 1, or 1, 7. So we have to decide which one is our interval of convergence. Beside this, we have said we have to test the endpoint is at f of x equal to 1. So let me check the endpoint is separately. So what's f of x? Here the value of x is 1. I'm going to take two cases. The case 1 is when x equal to 1, this part, or the first endpoint. This result is in our power series will be from 1 to infinity of 1 minus 4 raised to n over n times 3 power of n. This is equal to infinity of 1 minus 4 is negative 3 raised to n over n times 3 power of n. So this is equal with summation as n run from 1 to infinity of negative 1 raised to n over n. This series is convergent by alternating series test. We have seen about the convergence and the divergence of alternating series test in our past videos, so you can check it for to check for the convergence of this series. Another case is case 2. Case 2, when x equal to the second endpoint or 7, then our power series will equal to n from 1 to infinity of 7 minus 4 raised to n over n times 3 power of n. This result is in summation as n run from 1 to infinity of, this is 3 power of n over n times 3 power of n. This is equal with summation as n run from 1 to infinity of 1 power of n over n. This is a p series. So by p series test, this series become divergent. So from those two cases, we have tested the endpoints individually, and at the first endpoint, our series become convergent, and at the second endpoint, our series become divergent. So in our interval of convergence, the first endpoint will be included, and the second endpoint will be excluded. This means our interval of convergence is equal to closed bracket 1 comma 7 open bracket. This is our interval of convergence, and the radius of convergence will be as we have seen in our last sessions. Here we have said a radius of convergence is equal to, for interval of convergence given as a comma b, the radius of convergence will be b minus a over 2. So in this part, thanks for watching, and if you have any question, please don't forget to put in a comment section, and don't forget to subscribe to Pi Engineering channel. And if you think this video is valuable or useful for others, please don't forget to share to your friends